Hello students. In this lecture we see some consequences of refraction. So the first one is refraction through the glass slab. Refraction through the glass slab. So we are considering incident ray ABE, which is incident at the point E on a glass slab. So as it is traveling from rarer medium to denser medium, we are considering the first medium as air, the second medium as glass. So as the ray is traveling from air medium to glass, from rarer to denser, it is moving towards the normal. It is moving towards the normal. Let I be the angle of incidence, R1 be the angle of refraction. So after changing its direction, it propagates in that changed direction till the end of the glass medium. So again it is at the point where there is a interface of two media, glass to air. So the light is now changing from glass medium to air medium. So as it is changing the medium of propagation, its direction also changes. Now here it is moving from denser medium to rarer medium. Now as it is changing from denser to rarer, it has to move away from the normal. Here is the normal. So it is moving away from the normal. So at the second interface, at the first interface, I is the angle of incidence, R1 is the angle of refraction. So at the second interface, R1 is the angle of incidence. As there are alternating angles, this angle will be equal to this because they are alternate angles. So R1 is the angle of incidence and E is the angle of emergence. Look at the emergent ray. Look at the emergent ray. When you extrapolate the direction of the incident ray, extrapolate the direction of the incident ray and compare it with the emergent ray. Both are parallel to each other. So the emergent ray is traveling in the same direction that of the incident direction, that of the incident ray. Only thing is it has shifted by certain distance. It has shifted laterally. So this displacement in the emergent ray with respect to the direction of incident ray is called as lateral shift. That is given by lateral shift D is equal to T. T is nothing but the thickness of the glass slab. T into sine of I minus R1 divided by cos R1. The second consequence is normal shift. Most of the time you have seen the water filled swimming pool. If you see the swimming pool filled of water, you see that the base of the swimming pool appears to be raised. It appears the base of the swimming pool is nearer. So the apparent shift has taken place. Or another example you can take is if you place a coin in a water filled bucket. If you place a coin in a water filled bucket, the coin appears to be raised. The coin appears to be raised. So there is a shift. There is a shift occurs in the position of the object, which is in the other medium, and the observer is in the other medium. If the object is in one medium and the observer is in the other medium, then there occurs a shift in the position, apparent shift in the position of the object. This is called as normal shift. So here you can see, suppose this is the denser medium and there is some object there is some object in the denser medium and the observer is in the rarer medium. And the rays of light travel from the object is nothing but which emits the light. So the rays of light are traveling from the object. Now they meet the interface of two media, the denser medium and the rarer medium. So as the ray is traveling from denser to rarer, the ray bends away from the normal. The ray bends away from the normal. Sorry. So for an observer, the ray appears as if it is coming from this point. So he sees only the refracted ray falling on his eye. So the direction of the refracted ray appears as if it is coming from this point. So the observer feels the object is at this point. The real object is at some other place. Due to refraction, the object appears at some other point. It appears actually the object is not getting shifted. It appears as if it is at some other point. So the apparent shift in the position of the object has taken place. So actually at what distance the object is? At this distance. So it is called as real depth. Really at this distance the object is placed. But at what distance it is appearing? It appears as if it is at the small distance. So this distance is called as apparent depth. Apparent depth. So the refractive index of first medium, this will be your first medium because the incident ray, wherever the incident ray is there, that medium is called as first medium. So the refractive index of first medium with respect to the second medium can be calculated by getting the ratio, by taking the ratio of real depth upon apparent depth. So object shift closer to the observer if the object is in the denser medium. If the object is in the denser medium and the observer is in the rarer medium, then object appears as if it is moved closer to the observer. Now we'll see what happens if the object is in the rarer medium and the observer is in the denser medium. If the object is in the rarer medium and the observer is in the denser medium. Here we are considering the denser medium where the observer is there and here is the object in the rarer medium. So the light rays travel from the object. They meet the interface as the light is traveling from rarer to denser. It has to move towards the normal. It has to move towards the normal. So the observer can see the refracted rays. So what is the direction of the refracted rays? He feels that the refracted rays are coming from this point. So he feels the object is at this point. Actually the object is at point O. So due to the refraction has occurred, the observer can see the object in the direction of the refracted ray. He feels the object is at point O dash. So again here you can write the refractive index of first medium, rarer medium with respect to denser medium is again real depth upon apparent depth. Real depth is smaller, apparent depth is greater. So if the observer is in the denser medium and the object is in the rarer medium, the object appears to be shifted away from the observer. The object appears to be shifted away from the observer. So whether the object is in the rarer medium or denser medium, the refractive index of the medium is given. Which medium? The refractive index of the first medium where the object is placed with respect to the medium where the observer is there, or refractive index of the medium where the shift is taking place with respect to the object, with respect to the medium where observer is there. The second consequence is early sunrise and late sunset. So when we are able to see the things when they are above our level of eyesight. If the person is standing over here, if the objects are above the horizon, this is the earth. So in general we can see the objects if it is above our eyesight level. If it is too above, then also we cannot see. If it is too below, then also we cannot see. So if the objects are at the level of our eyesight, then only we are able to see the things. In the same way, if the sun is above the horizon, when it comes above the horizon, then only we can see the sun. That is called as the sunrise. When we say sun is rising, when he comes above the horizon. But due to refraction, we are able to see the sun before he crosses the horizon, before the actual crossing of the horizon by sun. Why it happens? So if the sun is below the horizon, here is the atmosphere. So if the sun is below the horizon, the light rays are traveling from the sun. So the space between the sun and the atmosphere is nothing but the vacuum. So the light is traveling in the vacuum. So when it is traveling in the vacuum, it is moving with some speed. As soon as it enters into the air medium, even though we say the light travels with the same velocity in air or vacuum, but actually the air is little bit denser compared to the vacuum. So when the ray is traveling from vacuum to air, it is a case of a light is traveling from a rarer to denser medium. So when the light travels from rarer to denser, where it moves? It moves towards the normal. So here is the refracted ray. So the observer can see the refracted ray and he feels the light is coming from here. So actually the sun is below the horizon, but due to the refraction of light from the sun, the observer feels the sun is at this point. So we are able to see the sun before the actual sunrise. It happens due to the refraction of light. And also we can see the sun a little after the actual sunset. Already the sun has set. Already the sun has crossed the horizon, but still we are able to see the sun. This also happens due to the refraction. So these are some consequences of refraction. Also, the twinkling of a star is due to the refraction of light. It doesn't mean that stars will emit the intensity of light emitted by the stars is not varying. Stars are emitting the light of constant intensity, but due to the refraction through the atmosphere, our eyes are receiving different intensities. Sometimes we receive more light from the stars, sometimes we receive less light. So this, because of this, the receiving of different amount of light, we feel the star is twinkling. It doesn't mean that star is emitting different magnitudes of light. It is emitting a constant intensity. So these all are some consequences of refraction. So go through both the videos, the refraction, refractive index, and consequences of refraction.